And now it also asks to sketch the total instantaneous waveform. Remember, the total instantaneous is that at any moment in time, meaning instant, what would I observe for IC if my gain, which is V out over Vn, is a 5 volts per volt. So for that, we need to first find Vc, and then we can find the AC current for IC from that. So the specifications again gave us that V out over V over your Vn was 5 volt per volt. And your input Vi is also specified as 20 plus 1 millisine 20t. And it is coming in here, and it's going through this capacitor. Remember, a capacitor is going to block the DC portion of that. And so going actually into it on the right-hand side of this will just be the 1 millisine 20t. So that part is what's going to actually be amplified. So my input that's going to be amplified is just going to be the 1 millisine 20t. And again, that's because the capacitor blocks the DC portion. So my output for the AC portion is just going to be 5 times this Vn. And so that gives me 5 millisine 20t. So this is the AC portion that's seen at V0. So the total current is going to be this branch in parallel with this one, so it's going to be 100 in parallel with 1K is the resistance that the current going in to the transistor will actually see. So the current here. I can also kind of draw that last part of the hybrid pi, which is where we see the characteristics of the AC portion. And drawing that, it would look like this. So I have 100. And then the capacitor is shorted here, so I have a 1K here. And this is the IC that is AC. And so knowing what this voltage AC portion is, I can get the IC AC portion as just VO AC over 100 in parallel with 1K. So this will be that current for the AC portion. So the DC current we found as 14.9 milli. And so if I was to draw this, actually first off, this value for the AC current is going to be the 5 millisine draw it down below. So the AC current, so the current at the collector in AC is 5 milli sine 20t divided by 100 in parallel with 1K. So that value ends up being 55 micro sine 20t. So my total current is going to be the DC portion, which is 14.9 milli. And now I'm going to see a sinusoidal wave around that value, where the peak of it is going to be 14.9 milli plus 55 micro, and the bottom portion is going to be 14.9 milli minus 55 micro. And so that would be what the actual waveform for the current at the collector would look like.